Good morning, everyone. Today I want to talk about multi-channel analyzer to study gamma rays. I will make 3 videos. The first one is the overview of the slide. The second one is how to use the Logger Pro to collect the data. The third one is how to analyze data to get our results. So this is the first video. The purpose of this lab is to study gamma rays. So first, what are gamma rays? So in this lab, we studied visible light, we studied X-rays, and both are due to the transition of electron from high energy state to low energy state. And gamma rays are much more energetic. They are due to the transition of the atomic nuclei. And the nucleus also have high energy state and low energy state. When they transit from the high energy state to low energy state, they emit gamma rays. And here are a list of the gamma ray energies. So for example, cobalt 60, there are 2 lines, 1.173, 1.332. And here are other elements. So the gamma rays for isotope is a characteristic of the nucleus, and it's unique. If we find some gamma ray given this energy, we can conclude it's produced by this isotope. And similar to atomic spectrum, by studying the spectrum, you can identify the element. And here, by this gamma ray energies are unique to the isotope. So if we find the energy, we can, for example, if we detected a gamma ray energy, the 0.662 mega electron volt, and we can conclude that the source of that energy, the gamma ray, is due to the isotope cesium-137. In astronomy, gamma ray bursts are extremely energetic explosions that have been observed in distant stars. Gamma ray bursts, so lots of gamma rays. And these pictures are computer simulation of the emission of gamma rays. And gamma ray bursts are actually not rare. This is a sky map of the gamma ray. And you can see it's pretty much everywhere in all directions, pretty isotropic. And there are scientists, they're analyzing the gamma ray bursts to help to study about distant galaxies or probably black holes. How to detect gamma rays? So in the previous lab, we used the Geiger detector to detect X-rays, and the Geiger detector uses noble gas and noble gas. And this detector, they tell us there is radiation or not, but we can't use a Geiger detector to measure exactly how much energy is the source. So to measure the energy, we use a solid state detector. So there are 3 types of solid state detector: scintillation detector, thermoluminescent dosimeter, and semiconductor detector. So we will focus on the scintillation detector. And the scintillation detector means that when the radiation comes into the detector, there will be light emitted. And this is the setup we will use. You see there are 2 elements. This is the scintillation detector, and you see the tube, and the bottom this is the tube, and you place the source at the bottom, and the radiation enters the tube here, and it is connected to this multi-channel analyzer. And there is a screen here, and we will see the pattern of this screen. And in this lab, one of the gamma ray source is due to this vase. So this vase is like greenish, because there is uranium, tiny amount of uranium, and that makes this vase radioactive gamma ray source. Okay, so now let's see how that this scintillation detector works. So this detector, we use the bottom is the sodium iodide and it's doped with a small amount of thallium. So thallium is the atom that makes the light emission. So you have the gamma ray coming here, collide with the thallium, emit light, and this light is detected by the photocathode. This tube is called photomultiplier tube, and because they can enlarge the emission of the electron. And these, you see, these are the diodes, and every time there is a reflection, more and more electron will be emitted from the diodes. And this eventually this is connected to a circuit and the amplifier, and the current is proportional to the energy of the gamma ray energy source. That's how we measure the energy. So this current go to the multi-channel analyzer, and the multi-channel analyzer has a memory, and this stores the energy depending on this stored energy at different address. So the address here we call them channels. So high channels store high energy, low channels store low energy. So they can detect the high energy source so they can detect several energy source at the same simultaneously. So we call them multi-channel analyzers. And the gamma ray source we use in this lab, there is a cobalt 60, cesium 137, and zinc 63. These are the radioactive sources. And we also have this potassium light salt and this vase. So we are interested in. Surprisingly, there is a gamma ray emitted from them, but the good thing is it's very rare, and it doesn't harm us. So we're still safe here because it doesn't happen very often, and for this lab to collect the data, it takes a long time. I really want to thank Dr. Stephen Walling. He took the experiment from the lab last week and did this experiment at his house. And here, this is the data he collected. So this is the graph you see from the screen of the multi-channel analyzer. And this is for the cobalt 60, and you see there are two peaks. And this is the cesium. There is one peak, and this is from the salt. You see the intensity is very low, and this is from the base. And you see here horizontally, this is the channel number, and to the right, that means high channel number, high energy. So the second peak means higher energy than the first one. But you also see other peaks here, other signal. This part is not zero. For example, this one here, and this one here. They are probably low energy gamma rays and also X-ray. So they are due to the interaction of the gamma ray with the matter like with the sodium iodide, and could also probably from the shield of the scintillator, the lead. And you have gamma ray coming into the atom. There could be photoelectric effect, so there could be X-ray emitted. And the gamma ray could also have pair production. They can produce electron and positron, and those are high energy particles, and they interact with the matter there, and so there could be low energy. You always see X-rays and low energy, low energy gamma ray. So we will only focus on the highest energy, the highest peaks. And so, for example, the cobalt, these two peaks, and the Vaseline, these three peaks. And we will just focus on the first few peaks we observe. And So for this lab, you want to, so this is the data we collect. This is the graph we made from, this is the made from the multi-channel analyzer. So we need, earlier I said the energy, so the energy of the radiation is proportional to the address of the memory. That address is called a channel number. So that means that we want to find out the channel number for each peak, the channel number for each peak. So we will use log to analyze those peaks, and use log to find those channel numbers for all the graphs. And but here I said, so you see the cobalt 60 and cesium, we know the energy, but for Wesleyan West and this salt, we don't know the source of the radiation. So you want to find the channel number, use the channel number to calculate the energy. So that means that we will use, I will stop here.